Hello everyone. Today we will be discussing the quick solutions of All India Akash Test Series JEE Advanced Test 4A Paper 2 Mathematics, which was held on 3rd April 2019. So let us start with the question number 41, which says that a circle C1 of maximum area is drawn lying entirely in the region R1 defined by mod x plus y plus mod x minus y less than equal to 4. Let P be a point lying in region R1 at the farthest distance from origin O. The point Q lies on the line joining O and P such that OP is equal to half of OQ. 4 options are given. So let us start it. Now, if we firstly solve this region, that is mod x plus y plus mod x minus y less than equal to 4. So we will get x less than equal to 2, x greater than equal to minus 2, y less than equal to 2 and y greater than equal to minus 2. Let us firstly plot the x and y axis, and the 4 lines that I get from here is x equal to plus minus 2 and y equal to plus minus 2. Let us say the region is this and the points are A, B, C and D. So here we are given a circle of maximum area whose center is origin O. So the circle would be something like this, right? And this point is here 2, 0. Now the position of point P. Now it has been given that point P is lying in region R1 and it is farthest from point O. So we can see that P can take 4 positions, that is A, B, C and D. Let us assume it in the first quadrant, right? That is at 2, 2. This is point P. Now it has also been given that OQ is equal to 2 times OP. So OQ will be lying on this line at something like this, right? So its coordinate will be 4, 4. We are taking it in the first quadrant, but Q can take 4 points, that is plus minus 4, plus minus. So let us see what option number 1 says. It says that the tangents from point P to circle C1 are at right angles. Now this is circle C1, and if I draw tangents from point P, that would be this one, T1 and T2. These two are the tangents and it can be seen from the figure that they are at right angles. So option number A is the correct answer. Similarly, let's take up option number B now, which says that area of the region bounded by the chords of contact of all such points Q with respect to the circle C1 is, right, we have to find chords of contact from point Q on the circle. We know the equation of chord of contact, that is T equal to 0, right? For option B, we will put T equal to 0. Now, equation of circle is, we know the center and we know the radius. So, equation of circle will be x square plus y square equal to 4. So, equation of chord of contact from plus minus 4, plus minus 4 will be plus minus 4x plus minus 4y equal to 4. That is plus minus x plus minus y equal to 1. We have to find the area of the region bounded by these 4 lines. Now, let's plot these 4 lines. It will be like this. It will be a square cutting x-axis at 1, 0 and y-axis at 0, 1. So, area of this triangle will be equal to half into base into height, that is half. So area of the whole region will be 4 times 1 by 2, that is 2 square units. But in option number 2, it has been given area as 1. So this option is incorrect. Let us now move on to the third option, which says that the tangents from point Q to the circle C1 are at right angles. So it can easily be seen from the figure itself that if I draw tangents from point Q to the circle, then they are not at right angles. So this option is also incorrect. Now option number D says that equation of the circle passing through the points P and Q in first quadrant with center on the line y equal to x is. Now we have to draw a circle whose center is on the line y equal to x and it is passing through the points P and Q. As center is on the line y equal to x, so PQ is a diameter of the circle, we can easily find the equation of the circle because we know the diametric ends. It will be x minus 2 into x minus 4 plus y minus 2 into y minus 4 equal to 0. This will be the equation of the circle. Let's solve it further. We will get x square plus y square minus 6x minus 6y plus 8 that is 16 equal to 0. And in option number D also the same equation have been given. So we can say that option number D is the correct answer. So the correct answer of this question will be A and D. Let's now move on to the next question, that is question number 42, which says that let C0, C1, C2 up to C12 be binomial coefficients in the expansion of 1 plus x raised to the power 12, and A12, B12 and D12 are given, right? So we have to find the relation between A12, B12 and D12, right? Now see, if I write 1 plus x raised to the power 12, it will be written equal to, I am writing 12C0 as C0, so it will be C0 plus C1x plus C2x square and so on up till C12 x raised to the power 12. Now if we replace x by omega, so we will get 1 plus omega raised to the power 12 is equal to C0 plus C1 omega plus C2 omega square. Similarly, the expansion will go on, right? Now this can also be written as C0 plus C3 plus C6, right? The multiples of 3 plus, if I take omega common, then we will get C1 plus C4 plus C7 and so on. Similarly, if we take omega square common, then we will get C2 plus C5 and so on, right? Similarly, if we replace x by omega square in equation 1, then what will we get? 1 plus omega square raised to the power 12 will be equal to, similarly I am taking constants in the first bracket, that is C0 plus C3 plus C6, plus taking omega square common, we will get C1 plus C4 and so on, and taking omega common, we will get C2 plus C5 and so on, right? This step is clear. Now further, we want the value of C0 plus C3. Let us say this is equation number 2 and this is equation number 3. Now equation number 2 can be written as 1 plus omega whole raised to the power 12 is equal to C0 plus C3 plus C6. This can be written equal to A12 plus omega into B12 plus omega square into D12. Similarly, I will write equation 3 as 1 plus omega square raised to the power 12 equal to A12 plus omega square into B12 plus omega into D12, right? Now let's take up option number A now. Option number A says that we have to find the value of A12 cube plus B12 cube plus D12 cube minus 3 times A12, B12, D12. Now we know its formula. It can be written equal to A plus B plus C, right? Now A plus B plus C is equal to, from equation 1, if I put x equal to 1, then we will get the value of A12 plus B12 plus D12 equal to 2 raised to the power 12. So I am directly writing it here, 2 raised to the power 12 into, in next bracket we have A square plus B square plus C square minus AB minus BC minus CA, right? And we know that it can be written equal to A12 plus omega B12 plus omega square D12 into A12 plus omega square B12 plus omega into D12. That is multiplication of the term written on the right side of equation 4 and equation 5, right? So that can be written equal to 1 plus omega whole raised to the power 12 into 1 plus omega square raised to the power 12. Now further solving this can be written equal to 2 raised to the power 12 into, we know that 1 plus omega square is equal to 0. So 1 plus omega can be written as minus omega square raised to the power 12 into 1 plus omega square can be written as minus omega raised to the power 12. Now multiplying these, we will get omega cube whose value is 1. So this will be equal to 2 raised to the power 12 So it can also be written as 4 raised to the power 6, and this is what has been written in option number A. So option number A is the correct answer. Now let us take up option number B, in which we have to find A12 minus B12 whole square plus B12 minus D12 whole square and so on. So expanding this, we will get 2 times A12 square plus B12 square plus D12 square minus, as 2 have been taken out, A12 B12 minus B12 D12 minus D12 A12. This is the value which we have to find. So this is equal to 2 times its value we have already found out in option A. It is equal to 1 plus omega into 1 plus omega square whole raised to the power 12. That has already been solved, equal to 1. So the value itself will be equal to 2. But in the given option it has been written 4. So this option is incorrect. And option number C will be correct. Now similarly take up option number D, which says that we have to find the value of A12 cube plus B12 cube plus D12 cube, as we have already solved option number A. So if D option would have been correct, then according to them value of A12, B12, D12 will be equal to 0, which is not the case. So option number D is also incorrect. So this question has answer option number A and C. Now let's move on to the question number 43, which says that values of theta satisfying tan 2 pi by 3 minus theta equal to sine 2 pi by 3 minus sine theta upon cos 2 pi by 3 minus cos theta is or are. Right. So taking up right hand side, we can write sine 2 pi by 3 minus sine theta upon cos 2 pi by 3 minus cos theta. So this can be written equal to, we know the formula of sine C minus sine D. That will be equal to 2 times cos of C plus D by 2, that is pi by 3 plus theta by 2 into sine of 2 pi by 3 minus theta upon 2, that is pi by 3 minus theta by 2. Upon applying the formula of cos C minus cos D, it will be equal to 2 into sine of C plus D by 2 into sine of D minus C by 2. Taking minus common, we can write it as pi by 3 minus theta by 2. Now it can be seen that this term can be cancelled from the numerator and denominator. So this can be written equal to minus of cot pi by 3 plus theta by 2. Now as on the left hand side the trigonometric ratio is given in tan, so let us convert it in tan. This will be equal to minus of tan of pi by 2 minus pi by 3 minus theta by 2. So this is equal to minus of tan of pi by 6 minus theta by 2, that is equal to tan of, taking minus inside, theta by 2 minus pi by 6. Now further we have reached at tan of 2 pi by 3 minus theta is equal to tan of theta by 2 minus pi by 6. Now we know its general solution, that is 2 pi by 3 minus theta is equal to n pi plus theta by 2 minus pi by 6, where n belongs to an integer. Now solving this further, we will get 3 theta by 2 plus n pi is equal to 2 pi by 3 plus pi by 6, that is equal to 5 pi by 6. So we can write 3 theta by 2 equal to m pi plus 5 pi by 6. I have replaced n by minus m. So further we will get theta equal to 2m pi upon 3 plus 5 pi upon 9, that is theta is equal to, taking 1 by 9 common, we will get 6m pi plus 5 pi. So this is the general solution. Let us put different values of m to get different values of theta. So let us put m equal to 1. So we'll get theta equal to 11 pi by 9. And if I put m equal to 2, we will get 12 plus 5, that is 17 pi upon 9, that is given in option number B, so that is correct. And putting m equal to -1, we will get minus pi by n, that is given in option number D. And if I put m equal to 0, so we will get 5 pi by 9. So from the given options, it can be seen that A, B, D are correct options. Minus 5 by 12 is not the solution of the given equation. Next is question number 44, which says that if z is a complex number with non-zero constant modulus, such that z square is a purely imaginary number, then we have to find the number of possible values of z. Now, it have been given that it has a constant modulus. Let us say z is equal to x plus iota y. So, it have been given to us that its modulus is constant, that is under root x square plus y square. Its modulus is equal to constant, let us say k. Also, it has been given that z square is purely imaginary. So, let us find z square. That will be equal to x plus iota y whole square, that is equal to x square minus y square plus 2xy into iota. As it is a purely imaginary number, so its real part will be 0. That is x square minus y square will be equal to 0. That is x square is equal to y square. So let us put it in equation 1. So we will get 2x square is equal to k square, that is x square is equal to k square upon 2, and y square is also equal to the same value. So from here we find that x is equal to plus minus k upon root 2. Similarly, y is also equal to plus minus k upon root 2. So how many possible values of z we have? Z is equal to x plus iota y. Also, z can be equal to minus k by root 2 plus k by root 2 into iota. Also, it can be equal to k by root 2 minus k by root 2 iota, or it can be equal to minus k by root 2 minus k by root 2 iota. So, we have 4 possible values of z. So, from the given options, we can see that option number B is the correct answer. Also, we have to find the sum of principal arguments of such z. Now, for this value, we can say that as value of k is positive because it is modulus. So, we can see that its argument will be pi by 4, and for this number, its argument will be 3 pi by 4. For this complex number, its argument will be minus pi by 4, and for the last one, its argument will be minus 3 pi by 4. Now we have to find the sum of the principal arguments. If I find sum of these 4 values, then it will be equal to 0. So from the given options, it can be seen that option number C is the correct answer. Next is question number 45, which says that let fx is equal to under root x square minus 4x plus 4 plus under root of x square minus 6x plus 9, and gx is equal to f of mod x. hx is equal to minimum of gx comma e raised to the power minus mod x. Then we have to find the minimum value of fx, gx, and so on. Right. So firstly, let's make the graph of fx, that is equal to mod of x minus 2 plus mod of x minus 3. How have I written that this? Because the value inside, that is x square minus 4x plus 4 is equal to x minus 2 whole square. Similarly, x square minus 6x plus 9 is equal to x minus 3 whole square, right? So from that I have written fx equal to this. Also, gx is equal to f of mod x. So it's easier to solve the question by making its graph. Now, if I take the value between x equal to 2 and x equal to 3, then its value will be 1. So it will be something like this. And for x greater than 3, at infinity the value will be infinity. So the graph is something like this. And for minus infinity, the value will be infinity. So the graph of fx is like this, where this point is y equal to 1. And this point is 0, 5. Now we have to plot the graph of gx. Gx is equal to f of mod x, which means that as the graph is in positive x, same graph will be repeated in negative x. So its graph will be changed for negative x, it will be like this, right? And here it is same. So this is the graph of gx. Now hx is equal to minimum of gx comma e raised to the power minus mod x. Gx we have already plotted. Let's plot the graph of e raised to the power minus mod x. Firstly, let's make its graph separately. Now, firstly, let's make the graph of e raised to the power minus x. Now, as x is tending to infinity, the value will tend to 0, and when x is tending to minus infinity, then the value is tending to infinity. So, the graph of e raised to the power minus x is like this. Now, to plot the graph of e raised to the power minus mod x, the graph as on positive x-axis will be repeated on negative x-axis, and we know that this point is 0, 1. So, the graph of e raised to the power minus mod x will be like this. Right? This is the graph of e raised to the power minus mod x. So, hx is equal to minimum of gx comma e raised to the power minus mod x. So, it can easily be seen that the graph of hx is e raised to the power minus mod x itself, because it have the minimum value. So, this is the graph of hx. Now, let's move on to the options, which says that the minimum value of fx is 1. We know the graph of fx, that is the brown one, and its minimum value is y equal to 1. So, this option is correct. Second option says that the minimum value of gx is 1. The green graph, it also have the minimum value 1. So, this option is also correct. Now, third option says that the number of solutions of hx is equal to e raised to the power minus mod x itself, right? So, the solution of this equal to 1 by root pi is. Now, the value of 1 by root pi will lie between 0 to 1. So, the line will be something like this. So, its number of solutions with e raised to the power minus mod x will be 2. Therefore, the number of solutions is 2. So, option number C is also correct. Now, fourth option says that the sum of the solutions of hx, that is e raised to the power minus mod x, equal to e raised to the power minus 1 by 2 is. Let us find its solutions. It means that mod x is equal to 1 by 2. It means that x is either equal to 1 by 2 or minus 1 by 2. So, the sum of solutions will be half plus minus half, that is equal to 0. But it have been given 1. So, this option is incorrect. So, question number 45 has answer as A, B and C option. Next is question number 46, which says that if a, b, c are non-zero real numbers such that 1 plus a upon a, 1 plus b upon b, 1 plus c upon c are in AP, and a, b and minus 2c are in GP, then we have to find whether these values are in AP or GP, right? It have been given that 1 plus a upon a. 1 plus a upon a can be written as 1 by a plus 1, 1 by b plus 1, 1 by c plus 1. These are given in AP. Now, we know that AP have a property that if I subtract 1 from all these three numbers, then also the numbers will be in AP. So, I can say that 1 by A, 1 by B, 1 by C is also in AP. Now, it means that A, B, C are in HP. Now, if A, B, C are in HP, then I know that B can be written equal to 2AC upon A plus C. So, this is the first relation that I get between A, B and C. Secondly, it have also been given that A, B and minus 2C are in GP. So, it means that B square is equal to A into minus 2C, that is minus 2AC. This is the second relation between A, B, C. Now, solving this further, we can write B square equal to minus into 2AC can be written as A plus C into B. So, cancelling B on both sides, because B is non-zero, I can write B equal to minus of A plus C. Now, this can further be written equal to 2B equal to minus 2A minus 2C, right? So, from here it can be concluded that minus 2A, B and minus 2C are in AP, which is given in option number C. So, option number C is the correct answer. Now, let us go option by option. Let us take option number A, which says that minus 2A, B and minus 2C are in GP. Let us check it. if they are in GP, then b square will be equal to 4ac. But in my case, it has been given that b square is equal to minus 2ac. So this option is incorrect. Now, B option, we have to find the value of a cube plus b cube plus c cube minus 3abc. So we know its formula. It is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. Now from equation 1 we can see that a plus b plus c is equal to 0. So we can say that a cube plus b cube plus c cube is equal to 3abc. That is given in option number B. So option number B is correct answer. Now let us take up option number D, which says that a cube, b cube and minus 8 c cube are in GP. Let us assume they are in GP. So I can say that b raised to the power 6 is equal to minus 8 a cube c cube. Now taking cube root on both sides, I will get b square is equal to minus 2 ac, which is true as can be seen from equation number 2. So option number D is also correct. So question number 46 have answer as B, C and D option. Next is question number 47, which says that the sum of all positive values of n, where n is less than 15, for which n factorial plus n plus 1 factorial plus n plus 2 factorial is an integral multiple of 49 is lambda. A very good question from permutations and combination. So let us solve it. Let us say the value n factorial plus n plus 1 factorial plus n plus 2 factorial. This is equal to, taking n factorial common, we will get 1 plus n plus 1 plus n plus 2 into n plus 1. That will give me n square plus 3n plus 2. Further, it can be written equal to n factorial into n square plus 4n plus 4, right? Which is a perfect square. So we can write it as n plus 2 whole square. Now we want that this should be an integral multiple of 49. For it to be an integral multiple of 49, either we can say that n factorial should be an integral multiple of 49, or n plus 2 whole square should be an integral multiple of 49. We have two cases here. Now, for n factorial to be a multiple of 49, we can take n as 14, as n is less than 15. So n equal to 14 is the only value that we get from here, because when we put n equal to 14 factorial, then we will get 7 also. So that will give me 49k. Now also n plus 2 square, it will give me 49 into k1 if n plus 2 is a multiple of 7. So n plus 2 will be a multiple of 7 when n is equal to 5 or n is equal to 12. These two are the only values less than 15. So we have these three values for which the given term will be an integral multiple of 49. So sum of all these positive values is equal to lambda, that is equal to 14 plus 5 plus 12, that is 31. So option number A says that lambda is a prime number, which is completely true because 31 is a prime number. Next, it says that exactly 2 of the values of n are prime numbers. Now from the given values we can see that only 5 is prime. So option number B is not correct. Option number C says that more than 2 values of n are prime numbers. That is also incorrect, right? Now option number D says that sum of the squares of the values of n is a multiple of 5. Let's find out. 5 square plus 12 square plus 14 square is equal to 25 plus 144, that is 169, plus 14 square, that is 196. So this is equal to 365, which is a multiple of 5. So we can say that option number D is also correct. Next is question number 48, which says that if a is a factor of 168, then the number of positive integral solutions of x1, x2, x3 equal to a is greater than or equal to. Now it have been given that a is a factor of 168, which means that a into a1 is equal to 168, where a1 is also a natural number, right? So putting it here, we will get x1, x2, x3 is equal to a. A can be written as 168 upon A1, that is x1, x2, x3 into A1 is equal to 168. Now we have to find the positive integral solutions of this equation. Now we know that how to find it. We can write 168 equal to 2 into 84. That can further be factorized as 2 cube into 3 into 7. Right? Now to find its positive integral solutions, let us see. Now 3 can be assigned to x1, x2, x3 or A1 in 4 ways. Right? 3 can go to any of these 4 values in 4 ways. Similarly, 7 can also be thrown to any of the 4 by 4 ways. Now let's talk about 2 cube. It will have 3 cases. That is, if I provide whole 2 cube to any 1, that can be done in 4C1 ways, plus that is in 4C1 ways I selected any 1 and I gave as a whole 2 cube to that number. Right? So that can be done in 4C1 ways, plus the next case is I break it into 2, that is 2 square and 2 raised to the power 1. So again I select any 2 from 4 by 4C2 ways and give them both by 2 ways. Plus next method is that I give 2, 2, 2 to any 3. So that can be done in 4C3 ways. Right? These are the only cases. So that is equal to 16 into 4 plus 12 plus 4. That is equal to 16 into 20, that is equal to 320. Now in question it have been asked that the number of positive integral solution is greater than equal to. It is greater than equal to 280. It is greater than equal to 320. So the correct answer is option number A and C. Next is question number 49, which says that the roots z1, z2, z3 of the equation x cube plus 3p x square plus 3qx plus r equal to 0 are affixes of the points A, B and C respectively. If the triangle ABC is equilateral, then which of the following may be correct? Now, for equilateral triangle which have the vertices as z1, z2, z3, we know directly the condition that z1 square plus z2 square plus z3 square can be written equal to z1, z2 plus z2, z3 plus z3, z1. This is the condition. Now we know from the given equation that sum of the roots, that is z1 plus z2 plus z3, will be equal to minus coefficient of x square, that is 3p, upon coefficient of x cube, that is 1. Next, z1 z2 plus z2 z3 plus z3 z1, that can be written equal to 3q upon coefficient of x cube, that is again 1. Now also we know that z1 plus z2 plus z3 whole square, its formula is equal to z1 square plus z2 square plus z3 square plus 2 times z1 z2 plus z2 z3 plus z3 z1. This is a very basic property, we know about it. Now this can be written equal to z1 square plus z2 square plus z3 square. From equation 1 it can be put here, so we will get directly 3 times z1 z2 plus z2 z3 plus z3 z1. This is what we get. So putting the value of z1 plus z2 plus z3 as minus 3p, we will get 9p square equal to 3 times. Now its value from equation 2 can be put as 3q. So we get p square equal to q. So this is the relation that we get between p and q. Now from the given options it can be seen that option number B and option number C satisfies the condition. So option number B and C are the answer of this question. Next is question number 50, which says that the number of solutions of the equation 3 times sine 4x minus sine square x minus 4 times 1 plus sine cube 4x is equal to 0, where x goes from minus 2 pi to 2 pi is equal to. We have to find the number of solutions of this equation. So it have been given that 3 into sine 4x minus 4 into sine cube 4x, and taking 3 sine x square on the other side, we will get 3 sine x square plus 4. Right? Now we know the formula. sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. We know this formula. So applying it here, we will get here sine 3 theta, that is 12x, equal to 3 into sine square x plus 4. Now here it can easily be seen that on the right hand side we have the function 3 sine square x plus 4. Now sine square x goes from 0 to 1. So 3 into sine square x will go from 0 to 3. Hence right hand side will belong from 4 to 7. And on the left hand side we have sine 12x that goes from minus 1 to 1. So the range of both are different. So we can see that we have no solution from this equation. So number of solutions will be 0, which are not given in option number A or B. So let us now check option number C, which says that the value of the remainder when n equal to 2 raised to the power 2007 plus 2008 is divided by 9. We have to find the remainder. Now this can be written equal to 8 raised to the power, as this is divisible by 3. Now here it can be written 669 plus 2008 can be written as 2007 plus 1. Further it can be written as minus of 1 minus 9 raised to the power 669 plus 2007 plus 1. Now let's find the remainder. When this is divided by 9, it will be equal to minus of 1. And in the next term, if we will expand it through binomial expansion, then it will all be a multiple of 9. So from here we will get minus 1 plus also 2007 is also a multiple of 9. So from here we will get 0 plus 1. So remainder is equal to 0. So option number C is the correct answer. Similarly, let's now check option number D, which says that coefficient of x raised to the power 2009 in the expansion of 1 minus x raised to the power 2008 into 1 plus x square raised to the power 2007. Now we know the formula of a cube minus b cube, that is equal to 1 minus x into 1 plus x square. So applying it here, we can write the value equal to taking 1 minus x common. Next we will get 1 minus x cube raised to the power 2007. This can further be written as 1 minus x cube raised to the power 2007 minus x into 1 minus x cube raised to the power 2007. Now we have to find the coefficient of x raised to the power 2009. Now from the first bracket it can be seen that we will get x raised to the power multiple of 3. Now it can be seen that 2009 is not a multiple of 3. So from here we will not get anything. Similarly, from 1 minus x cube raised to the power 2007 also we will get multiple of 3. Multiplied by x, we will get from here x raised to the power 3k plus 1. But it can be seen that 2009 is equivalent to 3k1 plus 2. So from here also we will not get anything, which means that the coefficient of x raised to the power 2009 in this expansion will be 0. So option number D is also correct. So correct option of this question will be option number C and option number D.